we have this limit definition of the derivative, and since it's a limit, we get theorems about properties of derivatives. Theorem 1, the derivative of a constant function is 0, my favorite number. Let's look at an example. So imagine we have a constant function, which just looks like a horizontal line. Y equals f of x is equal to k, which is some constant, just any real number. All right, remember that the derivative measures the rate of change. That's the slope. So what's the rate of change of this horizontal function? Yeah, it's 0. So the derivative is 0. That makes sense. Next theorem, the power rule. So let p be any non-zero number. All right, then let f be the so-called power function. F is the function f of x equals x to the power of p. These types of functions are easy to differentiate. Then f prime of x is p times x to the p minus 1. So the exponent comes down, and then we drop the exponent by 1. So for example, if f of x is x to the 1, certainly a real number, it's like the line y equals x is the graph of this function. All right, what's the slope of the line y equals x? It's 1. So how does that square with the power rule? Let's apply the power rule to x to the 1. You get 1 times x to the 1 minus 1. That's 1 times x to the 0, which is just 1. Some less obvious power rule derivative examples. Well, I'll start with an obvious one. So the standard, not complicated derivative of x to the 5th, bring down the exponent 5, becomes a coefficient, and then the exponent goes down by 1, 5 times x to the 4th. All right, but a little less obvious, what about the derivative of square root of x? Does that look like a power rule problem to you? Well, it helps to rewrite square root of x as x to the 1/2. That makes it more obviously a power function, so the 1/2 becomes a coefficient, and then the new exponent goes down by 1. And now you can use algebra to rewrite this in a few different ways. This is the same function written in a bunch of different ways. I would give full points to any of these. Another way where it can be less obvious, let's look at an example where we have a 7th root of x to the 5th. So if you use properties of exponents to rewrite that as the derivative of x to the 5 over 7, it becomes straightforward to apply the power rule. All right, and then one last example where the derivative is easier if we do a little bit of algebra first. So let's take the derivative of the rational function x to the 3rd over x to the 7th. Now you could use the quotient rule on this, but I don't recommend it. It's easier if you do a little algebra first. Cancel out those exponents, you get x to the negative 4, and then we can apply the power rule in a standard way. Next rule, constant multiple rule. So, say we have a function, say we know how to differentiate, that means we know how to find the derivative of some function, just call it f. All right, then we can just as easily differentiate the related function 7 times f. And it's the easiest thing it could be. It's just 7. So the derivative of 7 times f is just equal to 7 times the derivative of f. So 7f prime. All right, there's nothing special about 7. We can replace it with an arbitrary constant k. The derivative of the function k times f is k times f prime. So you can pull out the constant multiple. An example with real numbers. Now let's take the derivative of 5 times x to the 6th. Well, this is going to be 5 times the derivative of x to the 6th. We can use the power rule for that. So that's 5 times 6 times x to the 6 minus 1, so 30x to the 5th. Recall differentiation is a limit, so it has limit properties, like the sum and different rules. So say we have two functions, f and g, that we know how to differentiate. All right, then the derivative of their sum, f plus g, is just the derivative of f plus the derivative of g. So f prime plus g prime. Just the easiest thing it could be. And similarly for differences of functions. The derivative of f minus g is equal to f prime minus g prime. So now with these rules, we have everything we need to differentiate any polynomial function. Let's look at an example. So let's take the derivative of the function 3x to the 7 minus 4x to the 3rd plus 18. Well, applying the sum and different rules and the constant multiple rule, it splits up into 3 times the derivative of x to the 7 minus 4 times the derivative of x to the 3rd plus the derivative of 18. We'll use the power rule on the first two terms. So we get 3 times 7 times x to the 6th minus 4 times 3 times x squared, and then the derivative of a constant is 0. Simplify as much as is useful to you. Don't spend a lot of time simplifying on tests.